Okay, we're going to do a little lesson here on solubility rules. So I'm going to give you a way to remember these solubility rules. So NAG is nag and SAG is sag. Nag is always soluble. So whenever they're combined with any other kind of a cation or a metal ion, they're going to always be soluble. They're going to dissolve in water. If we look at SAG, they are mostly soluble, but they do have a few exceptions, and we're going to talk about that as we go through this lesson. So let's kind of focus in on the NAG part. So looking at the NAG, we see that the N stands for nitrate, and I also included chlorate there. So nitrate, chlorate, and there are the two ions. Acetate, there's the ion for the acetate, and then we have group 1. So group 1, just like you see it on the periodic table, includes everything in that group except for hydrogen. Okay, hydrogen is not part of group 1 as far as these rules are concerned. Then on the right side here, I have the S, which is sulfate, the A, which is ammonium, NH4, and then the G, which is group 17, so from fluorine on down. Now, before I move on here and I look at a couple other things that I want to address, I want to put a little star there by the ammonium and just remind you that just like the ions in the NAG, ammonium is always soluble. So we're only going to really focus in here on the sulfate and the group 17 ion. So as I scroll down, I'm going to talk about what would cause the sulfate and that group 17 ion to precipitate out. What's going to cause it to form a solid. So what would cause the sulfate in the group 17 to precipitate out? And when we talk about precipitate, the symbol that we're going to use for precipitate is going to be an S. Okay, that's going to tell me I produce a precipitate through the reaction. Okay, if something is soluble, then what's going to be the symbol for that? It's going to be AQ. Let me see if I can fix that real quick here. AQ. There you go. Not the most perfect thing, but oh well. So let's talk about these two things I have listed down here, which one is PMS and the other one is Castro-Bear. So you'll see that PMS is made up of a specific ion of lead, which is the positive 2 charge, mercury 1, and there's a formula, and silver, right? There's a formula for those ions. Castro-Bear is made up of calcium, strontium, and barium, which are all positive 2 ions that are found in group 2. So what can I combine with the sulfate ion that's going to produce this solid up here? Well, if the sulfate ion is combined with from anything from PMS, again, if the sulfate ion is combined with anything from PMS, it's going to cause it to produce a solid. What else will cause the sulfate to precipitate out? Anything from Castro-Bear. So any of these elements that I have, or these ions, excuse me, I have listed down here, if you see them in combination with the sulfate ion, they will produce a solid. Okay. So let's take a look now at group 17. What will cause the elements in group 17 to precipitate out? So only the elements here from PMS are going to cause the elements from group 17 to precipitate out to form that solid that we were talking about up here. So now that we've kind of just reviewed these or gone over these solubility rules, let's see if we can apply them to a few examples that are located down here on the bottom. So let's scroll down here to the bottom and I see a few examples. So taking a look at the first example, we have magnesium hydroxide. Magnesium hydroxide is a very good example for us to kind of start with, because what I'm going to do is I'm going to look for the negative part of the formula, that anion, which is a hydroxide. I'm going to scroll back up and I'm going to look for hydroxide in my NAG/SAG, and I don't see it there. Since I don't see it there, I'm going to assume that it's going to produce a solid precipitate whenever it's combined with something in a compound. Now there are some exceptions to that, but for right now, we're going to say that it is producing, or it's going to produce a precipitate. So we get a solid there. And we're going to do the same thing. Look at the next the next compound, and I see the chloride ion, okay, which is that negative ion part of that formula. I'm going to go back up, and I see that this time it is following one of the rules we have here. So it's group 17, and we talked about the only thing that will cause group 17 to precipitate out is either lead, mercury 1, or silver. So it is combined with silver, so then it's going to produce a precipitate, so we'll put an S there. The next one, you have ammonium and you have sulfate. Again, I'm going to look at the ammonium here, sulfate, and I see the sulfate ion there. I'm going to scroll back up, and this one's kind of a tricky one because you see that here I have two things that are part of my rules that make up that compound. Remember that I told you that ammonium is always soluble no matter what it's partnered with, it's going to produce an aqueous solution. So even though the sulfate can produce a solid here, it's going to be um, aqueous because it's combined with that ammonium. So we're going to put AQ there. The next one down is iron to carbonate. So I'm going to come back up. Again, I see that carbonate. I'm looking for that carbonate ion. I'm going to stop highlighting the negative part here to speed it up. So I see that the carbonate ion is not up here anywhere. So since it's not up here and I can't apply a rule to it, I'm going to assume that it's going to produce a precipitate. So it's going to be solid. I see cesium sulfide. Again, here, this one's kind of a tricky one because sulfide is not a part of my rules up here. I don't see the sulfide ion, that S2 minus ion, but I do know, or I should know, that cesium is in group 1. And because cesium is in group 1, that means that it's always soluble, meaning that it's going to produce an aqueous solution. There is no precipitate here. So that's going to be AQ. The next one here we have is zinc chloride. Okay, scrolling back up, I should know now, worked a couple of these, that the chloride ion is in group 17. They are mostly soluble unless they are partnered with something from PMS. Zinc is not a part of PMS, so that means that it's going to remain aqueous. And then finally, the last one is aluminum sulfide. So I go back up and I look. I don't see the sulfide ion anywhere up here. So since it's not in my rules and I can't apply a rule to it, I'm going to assume that it's going to produce a solid. So this is going to be a solid precipitate. So those are some examples. Hopefully I was clear on what I was discussing or describing to you. If you have any kind of questions, you can submit them to me by email, and I can always go over a few more examples for you, or I can demonstrate a few more examples the way we're doing it here. Unless you need something a little bit further or have some kind of a video conferencing, I can do that as well. But for now, I'm going to kind of stick to this format just to keep things simple. All right, so hopefully this helped. Have a great day.